Hello everyone. So let's continue with the type 3 integration of trigonometric functions related problems. So in this, what we are going to observe is how they are giving us the trigonometric ratio in the denominator and how we are going to solve these type of problems with the help of rationalizing. So when we have something of in the denominator in the format of 1 plus sine x or 1 plus cos x, or and then we have secant x plus tan x, something where we are unable to do anything with our integration formulas. In that case, we take a help of rationalizing the denominator. So let me just consider this to be equal to I, and then what I would be doing is I is equal to integral 1 by 1 plus sine x, and then into 1 minus sine x divided by 1 minus sin x. If my denominator is of plus sign, what I mean to say is if I have a plus sign here, that would be getting changed to minus here in both the places. That's how the rationalizing works. Other terms would remain as it is. So in rationalizing, we would be doing using this format. Now, if you just observe the denominator, it is a plus b into a minus b in the denominator, what we have. So in that case, it is going to be a square minus b square, which is 1 minus sine square x. Then I would be having my numerator as 1 minus sine x dx. So here one more thing. What is 1 minus sine square x? We would have seen cos square x plus sine square x is equal to 1. Then in that case, 1 minus sine square is gonna be equal to cos square x. So that is what I'm gonna put here. And then we have 1 minus sine. Now you would be able to see the difference from the question part and here. In the question part, when I had two terms in my denominator and in the numerator, we didn't have anything or a one term in my numerator when I may not be able to proceed with my problem. In that case, the rationalizing helps in order to make that one single term into in the numerator as a two term. So that now I would be able to split up and write it as 1 by cos square x dx minus sin x divided by cos square x dx. So integral 1 by cos square, what is 1 by cos square refers to secant square x dx, and then here we have sin x divided by cos square x, which is nothing but cos x into cos x. So here sin x by cos x becomes tan x, integral tan x, and then 1 by cos x is nothing but secant x dx. So now if you observe, we have integral secant square. Secant square is nothing but tan x. And then minus, we have tan x secant x, which is nothing but secant x plus c. Just observe here, we have integral secant x tan x or tan x secant x, both are same. So that is going to be secant x plus c. So here, totally, this is how this problem has to be done. So tan x minus secant x plus c. Now, let's go on with the second question. Similar type of approach, but we would be doing it with the cos. So 1 by 1 plus cos x dx. So in this question, what we would be doing here is first we would be considering it as I. And as you observe, just have a look at the numerator. In numerator, I have only 1. So, and the denominator, when you observe, you are able to find two terms. In that case, with a trigonometric, whenever you find, we can go ahead with the rationalizing. So now here what I would be doing, I is equal to 1 divided by 1 plus cos x. In that case, when I'm rationalizing, I need to multiply with 1 minus cos x. That's how the rationalizing works with both the numerator and the denominator. Now in this case, I would be having 1 minus cos x divided by 1 minus cos square x dx. Now here 1 minus cos square x, see we had cos square x plus sin square x is equal to 1. Then in that case 1 minus cos square x is equal to sin square x. Now let me just go ahead and substitute it there. 1 minus cos x divided by sin square x. And now the entire problem, so we had one person in a numerator that has been changed to two terms here. And then two terms in the denominator has been changed to one term, where I would be able to do the splitting. Just because of that reason we are doing it. 1 divided by sin square x dx minus integral cos x divided by sin square x dx. Now 1 by sin square x is nothing but cosecant square. So integral cosecant square x dx, and then minus here what we have is cos x divided by sin x into sin x. This is going to be cot x into cosecant x. So it is minus cosecant x cot x dx. Now let's substitute the integration formula directly. This is going to be minus cot x, and this is going to be minus of minus cosecant x plus c. So this becomes minus cot x plus cosecant x plus c. That's it. Hope you understood. Now I'm moving on with the next one. We had the numerator as 1 in these two problems. Now let me change the numerator, but still we would be rationalizing. So let me have look at that. Question goes something like this. Sin x divided by 1 plus sin x dx. Again, we would be going ahead with the same rationalizing. Before that, let me consider this as I is equal to, then I would be sin x divided by 1 plus sin x into 1 minus sin x. See, rationalizing. The same terms I would be having as my denominator, but the plus would be getting changed to minus. That's the only change. Now after this, what I would be having here is my denominator is gonna be a plus b into a minus b is gonna be a square minus b square, that is 1 minus sin square x. And the numerator is gonna be sin x into 1 minus sin x. So dx. So let's see what exactly is happening here. Um, See, the denominator part is 1 minus sin square x is equal to cos square x, which we have proved already. The same thing I would be writing here as cos square x. And then I would be having sin x minus sin square x in my numerator after the multiplication. Now let me just split and write. Sin x divided by cos square x dx minus sin square x divided by cos square x dx. So now here, what we would be having here is sin x by cos x is gonna be tan x, and then 1 by cos is secant x dx. I told you how it works in the previous one, so I'm just writing it directly. Now sin by cos is tan, but we have sin square by cos square is gonna be integral tan square x dx. Now again, one more trouble. We don't have integration directly for tan square. Let's have a check with the formulas which I have listed. Nowhere I have tan square. So, but I have secant square, but I don't have for tan square. So now the case is, but we have for integral tan x secant x, but let me do the change and all together let me integrate. That's the reason I'm writing it again. Minus integral tan square x, I can write it as secant square x minus 1 dx This I would have told in the previous video how this is like how we are taking it as secant square x minus 1. You can have a check there, but this time I'm writing it directly. So now here, finally, let me go ahead with the integration. We have integral tan x secant x dx minus integral secant square x dx plus integral dx. So this is gonna be integral tan x, this one, secant x is gonna be secant x. And then here I would be having minus tan x plus x when I integrate dx and then plus c. That's it. Now, one more question to go, or I would make it as three more. Let's have a check with that. The question goes something like this. Secant x divided by secant x plus tan x, and we have dx. Observe how the question is. The question is of the format one term in the numerator, but I have two terms in my denominator. So in that case, I need to reduce the denominator term as a one term, that is trigonometric term. So with the help of completing the square. So what I would be doing first, considering, sorry, not with the help of completing the square, rationalizing the denominator. So here, what I would be doing is secant x divided by secant x plus tan x into secant x minus tan x divided by secant x minus tan x dx. So what we would be getting here is, in the numerator, we would be writing it as secant x into secant x minus tan x divided by, see here, a plus b and then a minus b, which is going to be a square. It's going to be secant square x minus tan square x. Fine. So now here, when you observe secant square x minus tan square x, I hope you guys recall, or even in yesterday's videos, we have posted that secant square x minus tan square x is going to be equal to 1. And that is how here we are writing it in this one. What is your tan square x? Tan square x is going to be secant square x minus 1. We have used it here in the problem. And now, even now here, what is happening? My denominator itself would go away. And I would be having only secant x into secant x minus tan x. And then dx. Multiply the terms. Multiply it, you would be getting it as secant square x minus secant x tan x dx. Now, do we have integration for secant square x? And do we have integration for secant x tan x? Yes. Since we have, we will integrate it. So when I integrate for secant square x, what I would be getting? I would be getting, so let me write one more step. Secant square x dx minus integral secant x tan x dx. So in that case, now when I integrate secant square x, I would be getting tan x and then minus secant x plus c. Okay, this is how the rationalizing thing would work. When we would be rationalizing, when we are having a trigonometric one, and then observe the numerator and denominator. When the numerator is of one term and the denominator is of two terms, then in that case, whether it is possible for me to make the denominator as one term with the help of rationalizing. This is how you need to think that particular time. Then if it is possible, go for rationalizing and then you would be able to solve the problem. So now we will go with a different approach of problem now. So here, fifth one, we have integral sine to the power 6x plus cos to the power 6x divided by Sine square x, cos square x, and then dx. Okay, so see here, this one what we have in the numerator, so that can be further simplified. So before that, let me just consider this to be I. So now here, whether you are able to observe the numerator as a cube plus b cube format. If not, I will just make it. Let's see here. I have a square, the whole cube, and then plus b square, the whole cube. This is nothing but a to the power 6 plus b to the power 6. The same way the question has been given with sine and cos. So I'm going to use that particular thing. What we are going to use is a cube plus b cube is equal to a plus b the whole cube minus 3ab a plus b into a plus b. How did we get this? We have a formula for a plus b the whole cube, which is a cube plus b cube plus 3a square b plus 3ab square. So now here, what we have done, this part has been given for me. So what I would be doing, I would be taking these two parts to the other side of the equation. So here I would be having a cube plus b cube is equal to a plus b the whole cube minus 3a square b and then minus 3ab square. Now out of this, whatever is common, let me take that in these two terms. I can take out minus 3ab as common. Then I would be getting b plus a. Okay, so in that, sorry, a plus b I would be getting. So from here a and then here b. So that is going to be a cube plus b cube. Though b plus a and a plus b both are same, but here the common thing is a, and here when I'm taking a, b, here I would be left out with a, here I would be left out with b. That's the reason a plus b. Now in this format, I'm going to write the numerator. So now we have sine square x plus cos square x the whole cube minus 3 sine square x cos square x, and then let me erase it. Minus 3 sine square x, and we have cos square x. Then a plus b, that's what was there. So here a is nothing but sine square x and then plus cos square x, then divided by sine square x cos square x dx. Now, what we would be doing here is, now again, trigonometric identities definitely we would be using. If you observe this part, let me just show it to you with a different color. This part, sine square plus cos square is equal to 1. And if you observe this part, here also sine square plus cos square is equal to 1. So now I'm going to do that change. So in that case, it's going to be 1 cube, right? So 1 cube. So I will just write it as 1 minus 3 sine square x cos square x divided by sine square x cos square x dx. So now here it is going to be integral 1 divided by sine square x cos square x dx minus 3 divided by sine square x cos square x and then sine square x cos square x dx. Then now what would happen? These two would be getting cancelled, right? And then here I would be having integral. Now see here, I have denominator, okay, but I don't have anything in the new. I have 1 in the numerator. And the 1 by sine square is cosecant square and then secant square. The product of cosecant square, secant square, we don't have any integration formula here. So it is not of any use, but we have something called 1 is equal to sine square x plus cos square x. This will help me. So now what I'm going to do, I'm going to replace this 1 by sine square x plus cos square x divided by sine square x cos square x dx and then minus 3 integral dx. Now here, let me split and write. It's gonna be sine square x divided by sine square x cos square x dx plus integral cos square x divided by sine square x cos square x dx minus 3 integral dx. Let's integrate together. And now what happens? This one gets cancelled and cos square gets cancelled. Here sine square get cancelled. I'm having integral 1 by cos square, which is nothing but integral secant square, right? This is gonna be integral secant square x dx. And 1 by sine square is nothing but cosecant square x dx minus 3 integral dx. Now we have a formula for secant square, cosecant square and all. So together we can. So it is gonna be tan x minus cot x minus 3x plus c. That's it. The problem might look complicated in the beginning, but the thing is that you have to know few formulas. Then in that case, it is very easy. One is AQ plus BQ formula, and then the other one where when I have one that has to be replaced by my trigonometry. That's it. With that, the problem gets over.